Excellent. And before I actually share my screen, actually, I just wanted to actually encourage everyone to actually take a moment. Actually, we're going to take a deep breath actually now as a workshop and think a little bit actually quite differently. In fact, actually, I'm going to encourage everyone to actually stand up and actually stretch. I'm going to actually use my own a little rising desk and I'm actually going to ask you in a second to turn on. Good. Thank you, Sitao. Actually, thanks for playing along. I'm going to actually ask you here in a second to play along with me because I'm going to ask you a few questions here, and I'm going to ask you to before describing myself, I'm going to because I'm obviously Neil Heffernan, and I'm going to ask you a few questions, and I'm going to, I'll tell you the questions first, and then I'm going to ask you to turn on your little videos and raise your hand. And because I want to actually find out, did any of you actually have kids actually doing math at home? And I'm gonna, or maybe a niece or nephew or a friend that you're actually trying to help learn math during the pandemic. I'm going to ask you, how often do you actually communicate with your kid's teacher during this pandemic, back in April and May, for instance? Once a day, once a week, once a month, never? Do you know your kid's math textbook? Or are you a loser parent like me? I actually don't know my kid's math textbook that they're using. I'm actually curious to know if you had a kid use one of these things, particularly if you're in the United States, maybe McGraw-Hill's ALEX or IXL, or if you know if one of your kids is using, say, Illustrative Mathematics or Engage New York, Open Up Resources. Then finally, I'm going to ask you, why are you at KDD? Do you create algorithms or are you maybe a little more like me where you're applied in a particular area? I'm curious to know from our audience a little bit. And my last question I'm going to ask you is, do you know anything about AI and Ed or the EDM societies? I can just show you these two images here. I'm going to encourage you to turn on your little video and share, because now I'm going to go back to these questions. Who, if anybody, actually has kids that they've been helping during this pandemic? And I'm actually trying to figure out where my mouse went. I'm going to stop sharing here for a second. I'm going to wait. I have a good teacher voice, and we will not proceed until we have some videos on, because we're going to interact a little bit right now. I used to teach middle school kids. I'm more patient than you. So turn on some videos here, because we're not going to proceed. I see one person turning on their video. Good. I now have 4 people turned on their video. I will wait. I see 4 people. There we go. March. We see 5 people turn on their video. Looks like I got 1 person to bail out of the room already. I want to know, who am I talking to? So, how about an easy one? Who's actually in China? Who's actually in the United States is the other question I want to ask. When I start talking about the work we're doing of applied KDD type stuff here, what actually matters. So, so when I teach my class at Worcester Polytechnic Institute, I refuse to actually have anyone not actually have their video on. So I'm gonna wait here, and I'm more patient than you. Let's go. See that 16-year-old behind me? Actually, he knows his dad is a hard ass and actually wants to actually interact with people. I'm not going to talk about my stuff until we actually get a little bit of action going on here. Let me start with actually my speakers that have already actually here and have their video on. How many of you actually, I know C. Dow, actually you only have a little baby, so you can't possibly be teaching your baby mathematics yet. But how about the other two guys? Do you have children? Who's got kids?
No.
Okay, no one has kids. Does anyone actually have to teach? Did anyone try to help anyone during the pandemic with mathematics? Thank you. And thank you very much. So someone is actually, what is your name? You're muted. Did I mute you? So, hold on. I'm going to ask to unmute. This actually person asked to unmute. I'm hitting this ask to unmute button. Let's go ahead.
Thank you. Yes. So I have a 19-year-old and I have been helping friends who are not used to teaching their kids at all at home. So the pandemic has been quite interesting. And I know my friends and their kids much better than I used to.
I'm going to talk about these issues and actually how teachers across the United States are using our system to do this sort of thing. And can I ask, what brings you to KDD?
So I'm doing my PhD. I'm a PhD candidate in visual analytics. And I was interested in assessments anyway, from a research standpoint. And then the pandemic happened and it all became applied very, very quickly.
Well, excellent. I'm going to actually also share some stuff about actually the open data sets we allow KDD, people that are excited about KDD to actually use. So, and I appreciate this. Who else actually wants to tell me something about actually who they are and why are they here at this workshop?
Sorry for background noise, by the way.
No, I didn't hear anything. And by the way, say your name. It's not Halem. Did you have to unmute yourself? Go ahead.
Actually, my name's Halima.
Halima.
Halim is a nickname.
Excellent.
Yes, so
nice to meet you.
Nice to meet you.
Let me hear from one other person before I proceed. My PhD student, March, actually knows he's a persistent actually guy. Am I going to give up? Actually, all right, I'm going to give up. Okay, actually, you people with your cameras off, you beat me. All right, I will proceed. All right. Okay, so let's see. Let's actually, don't come take my class, actually thinking you're going to be able to keep your camera off. So, all right, so who the hell am I? I'm actually Professor Neil Heffernan, actually, and I got at least learned one person actually had difficulty during these COVID times, actually, and I didn't get to know anybody about actually which math textbooks or software you're aware of. But these are going to be really important. So anyways, I'm a professor at Worcester Polytechnic Institute. I teach artificial intelligence, and I have actually over 80 peer-reviewed actually papers where we're doing educational data mining, where we're trying to actually build slightly better predictive algorithms. And most of the time, those actually slightly better algorithms aren't really important. It's really easy as an academic to fool yourself into thinking you've done something important just because you get slightly better predictive sorts of stuff. What I'm going to talk a little bit about is actually how do we actually use these slightly better predictive sorts of stuff to actually how do we use these predictive algorithms to take action? Because what it's really all about is taking action. And so I'm going to actually try to tell you about some of that. And in particular, the taking action, when I think about taking action, is I've actually published 24 peer-reviewed randomized controlled trials using assessments as a platform. What we really want to do is figure out what should we give to a given kid actually of the options that we actually have for them, right? Like that is what this is supposed to all be about. Otherwise, we're just like predicting stuff and it's not actually very interesting to me. So, all right, the last time I was at KDD, actually my student actually won actually the best, one of the best student prizes for the KDD Cup. I think that was in 2010. And so I actually think of myself as a KDD type researcher, though I actually don't often show up at KDD because it's not actually, on average, not actually very educationally orientated. And so I care. In fact, my PhD student, March, who has his video on, actually has helped me run 2 big competitions where we actually got over 70 researchers, I think in both cases, to actually, in this case, do data mining on actually what's called the Nation's Report Card here in the United States. Actually, I already mentioned something in the chat about actually the U.S. Department of Education's Institute for Education Sciences. They run something called the What Works Clearinghouse. I'll mention that again in a bit, but they also run the Nation's Report Card, or what's called NAEP, that is the National Assessment of Educational Progress. And we ran a competition to try to actually help data miners do something really important, which is help actually look at the clickstream data while children are doing NAEP to figure out, can we build a model of actually which kids are going to essentially stop working on the NAEP exam. It's a huge problem in the United States because NAEP actually helps us keep the trend line in America. We can't tell if actually kids are getting better or worse if over time, maybe actually kids are less likely to pay attention on NAEP. And so we ran this competition. And by the way, all these competitions are publicly available, released data sets, and I encourage people to come along and beat the crap out of actually my students and myself and others to try to actually do a better job of making these predictive algorithms. A year and a half ago, actually, we ran a competition using assessments data sets. In that case, we were using 7th grade use of assessments to predict who actually goes into a STEM career. Yes, I really mean that, yes, we're trying to predict 10 years after they used their 7th grade math software, actually, how are they doing? We had already actually published a series of papers related to who actually finishes, who does well on their state exam in 7th grade, who actually goes on to college, who goes into a STEM career. And so it was logical for us to actually then run a competition in saying who goes into a STEM job. Everyone talks about early dropout detectors to figure out who actually drops out. Wouldn't it be great if we had an early losing interest in STEM actually detector? And so we did this competition. So pretty much everything I'm going to talk about, actually all the papers I'm going to talk about will mostly actually all be involving places where we've released data sets. I'm really pleased to the fact that because I've released a lot of data sets, I'm aware of at least 43 papers that have actually used our open data sets. And I think there's 6 different types of data sets that I see getting used a lot. And a lot of people have used the assessments data sets number 1 and 2 actually listed on here. And my team is actually releasing new data sets this year. And particularly we're releasing actually in the next few weeks, a data set on before COVID and after COVID. And that will include a bunch of stuff that is not actually typically released or we've never released in the past, including, among other things, data that would actually help us do stuff like, did your teacher actually during COVID times check on their assessment reports? Can we see which kids are likely to drop out and stop working? Because let's be clear, we all know during these COVID times, okay, that actually lots of kids are going to stop working. It was already happening before COVID. We have a big problem, at least here in America, getting kids to stay focused. And we still lose only 25% of American kids don't finish high school. And so, yeah, 25% of kids still in 2020 are not finishing high school. So we have lots of kids dropping out of school. And during this COVID times, we're going to have more and more kids actually failing to actually proceed. So how do we build software that will hopefully help teachers keep their kids interested and engaged and moving forward? So I can't do any of this without actually mentioning my wife. My wife actually runs the Assistance Foundation, and we both met teaching middle school math in Baltimore, Maryland. I was a Teach for America kid, and my wife was a Peace Corps volunteer. And I appreciate the smile, actually. And it's important to have an audience. And so anyways, my wife actually is out gardening right now, actually during this pandemic. Actually, she said, I'll just stay out of the kitchen, dear. But really, she and I actually lead a big team of actually people. If I have some superpower in life, it is not invisibility or the ability to fly, but I write grants well. And so I have a big team actually at the university that are helping me. I'll wind up talking about them. But what is Assistance? It's just a dumb platform that teachers can use to build their own content and assign problems and by the way, when I say content, I really mean to say problems and feedback. Most of the teachers are mostly focused on, I want to assign these problems that my kid already has, or that my school bought this textbook, or actually my school is using this open educational resource, or I decided to use this open educational resource. I'm going to talk to you about that in a second. But teachers draw questions from our library or make their own stuff. Students get instructional assistance while teachers get assessment, thus the name Assistments. And I will point out that actually the 6 letters of assisting is actually the insisting part, which is actually that's the important part. It's really not about the assessment, though actually we got kind of famous like 15 years ago because we did a good job of predicting who does well on their state test. But every 7th grade teacher already knows who's going to do well and who's not going to do well. That's not very interesting. How do we actually help them though is interesting. So if you go to Assistments, you can actually learn a little bit about it. This is actually the main site. And there's these open educational resources. Half of American teachers say they've actually used Engage New York or Eureka Math, one of these freely available actually things. Basically in America, we actually have a little bit of a revolt against some of these traditional textbook makers. And so that actually has provided a lot of actually use. But we've actually also taken actually a bunch of other textbooks, and a big study we're going to talk about that was in the What Works, that got us into the What Works Clearinghouse, got me invited to the White House back at a time when you still wanted to get invited to the White House in 2016. Because we took every textbook in the state of Maine and did a big, huge study. I'm going to tell you a little bit about that in a second. I'm also going to tell you about Skill Builders. Skill Builders is our version of something that is adaptive, where kids keep working until they get 3 right in a row, and we have something like 300 actually Skill Builders. The data set that I mentioned a second ago, the most commonly used data set from Assistments in publications, at least like 20 odd researchers have used actually the Assistments data set, mostly about the Skill Builders. But March and some of my team are helping me actually show something else off. Anyways, I want to show you actually how a teacher assigns something in our OER. OER is our term of art for Open Educational Resource. This actually is a video actually showing, if you go to Assistments right now and you click on say a Luster Mathematics and you click on say 7th grade and you're doing unit 2 and you actually click practice problems, and maybe you're a teacher and you're on lesson 2, teachers can pick which problems they want to do. They can scroll down. Oh, I want this one. I don't want this one. If you're a student here in America, you know, your teacher picks some questions and hands them out to you. Here, actually, I'm demonstrating actually assigning in Google Classroom. The name of the class happens to be Class with Vincent. I just gave a talk at Carnegie Mellon where I came from. I'm going to go click on View here in this example. Now we're into Google Classroom. If you don't know about Google Classroom, it's the fastest growing learner management system used in the United States. We did a simple integration with Google Classroom. We're still in Google Classroom. Here we're looking from a teacher perspective. The teacher hits this button. Now they're back at Assistments. And now they can see that the one person in my class named Christina Heffernan actually has done nothing, but that's because I just assigned it. Here I'm just going to demonstrate from the user perspective. Here's a kid. Now I'm demonstrating as a kid. I'm answering an open-ended question with a gaming sort of answer, and I'm clicking through some hints just to demonstrate what hints are. And their eventually correct answer is 4. Type 4, boom, and go on to the next problem. Maybe we'll who knows what, I don't remember whether I got this problem right or wrong. Oh no, the video ends here. Anyways, I showed you 2 problems inside assessments. So the builder is important too. Actually, in fact, actually, if you want to understand how assessments is different than many actually commonly available actually things, it's really about teacher choice, teacher creation. And so it is an anathema to us that actually anyone would use an educational product that doesn't allow teachers to modify and put themselves in the place of doing this. But every MOOC on the planet, actually, it's not about that at all. And so anyways, I'll say a little bit more about that. I'm going to play a little video to just demonstrate. We have a really stupid builder. Again, I got a dumb platform, okay? And then we build some mildly intelligent things around it. Anyways, a person can say, what is 2 + 3 and put in the answer of 5, and they can type in a hint, count on your fingers. And now that's inside our system. I think we can actually ask a question. I think I was like, yeah, what are the causes of the Civil War? And I'm sure I don't even bother spell checking this stuff because I just made this video very quickly. And clearly the answer's got to have something to do with slavery, or you don't understand what's going on. I think this video might actually demonstrate. We're going to play that thing here. One thing we do a lot of is actually algebra. Since we're a math site, actually, I think I'm now about to demonstrate in this video. Essentially put this in slope-intercept form. 4x + 2y = 12. As you might imagine, our system does the right algebra. So if a child actually puts this in actually wrong. Anyway, we're making a problem right now, and we're going to put in the answer. I can't. My mental math is actually really bad, so I can't really remember how to do this really quickly, but luckily I made a stupid video here. I'm gonna actually hit create on this little video, and then I think I'm actually also gonna demonstrate, all right, I actually had to mark the answer type here and then hit create. You'll see my AI class is actually listed here, WPI Teach AI CS 4341, and now we've made a problem set. Actually, that's the builder. Okay, I just actually, I left my video, boom, boom, boom. Okay, here we go. In a nutshell, so we're a dumb learner management system platform that gives actually teachers the ability to find, modify, create new problems for their students to practice on and give due dates and then reports. And I wrap actually some interesting supports around what teachers want to do, or at least that's our goal. And in particular in this talk, I'm mainly going to focus on actually my vision of actually how do we actually use platforms like mine to actually crowdsource stuff. Many of us that are programmers know like Stack Overflow is amazing. Like who hasn't actually typed in a question and you got Stack Overflow comes up with an answer. Wikipedia is amazing. Why don't we actually have this in K-12 where we actually have platforms that allow us to crowdsource stuff from teachers. So while I teach artificial intelligence, I don't believe in artificial intelligence. I tell all my students I don't believe in artificial intelligence. I believe in teacher intelligence. How do we actually crowdsource content, that is content for students, hints, explanations, scaffolding questions. I didn't show you that, but I might. YouTube videos, or content to give to teachers, what we call instructional recommendations, or new problems they might want to assign, or the mapping of problems to skills. So my worldview is actually shaped by this. So anyways, I already mentioned if I had some superpower, it's actually grant writing. And so I have 19 funded projects right now. There's a bunch of them in blue that is actually about actually just building up the crowd. And so we have a bunch of big efficacy trials that we're running. But what I really believe in, actually, now what I think is important is here in red is I have a bunch of things where we're actually just crowdsourcing different pieces of stuff from teachers. Almost all of our grants involve getting some teachers involved. They actually are either writing explanations or actually answering kids' questions and then giving kids feedback. And we're trying to machine learn actually from these things to figure out who to give what to. So instead of actually talking about those 7 or odd grant actually names, I just want to say there's stuff that we give just-in-time support to students. That's the stuff that we spew right out immediately. But I think it's a really underestimated role, which is actually how do we support teachers on content for given problems, or maybe even across problems. And I'll try to actually be more precise about that in a second. At the end of this talk, I'll talk a little bit about e-trials, which is another portion of my work where we actually use our platform to actually help other researchers do their own studies. So during the pandemic, actually, we had 6,000 teachers in March actually make an assessment account. We normally had them about 300 a month normally would have actually been having. So obviously during the pandemic, we had all these teachers say, holy cow, we actually need something. So they actually flocked to us. This map is out of date because we've been busy doing other things, but we have 300,000 users right now. I think actually something on the order of, or certainly over 10,000 teachers and 300,000 kids. And I think actually our number of problems solved, I think is over 100 million. So what is assessments? Assessments is feedback. I guess I demonstrated that. It's also, but it really actually is focused on actually having a strong role for the teacher. I don't really believe in actually the sort of vision of like, oh, the computer's got artificial intelligence and it will actually do everything. Teachers exist for a reason. And my kid actually failed in online education, even though he's taking a class on Java, and his dad is actually down the hall. Yep, my boy failed Java that I teach for a living, actually. And why? Because during the pandemic, like we're like, oh, you don't have to hand stuff in on time, and then actually winds up procrastinating. And my boy probably never would have failed if he actually had to look a real teacher in the eye every day and realize, you haven't done anything, Tom. What have you done in the last week? So let me show you from the perspective of actually how assessments was used before we actually had a pandemic. I'm going to play this video for you. Oh yeah, right. And
take out your homework from last night. Here are the answers.
Let me pause for a second. Everyone in America actually recognizes this sort of thing. Like if you were lucky, your teacher at least bothered telling you the answers, right, for problems you did last night. But that to me drove my wife and I crazy. Like, why do kids have to wait until actually tomorrow? Here's our experimental condition.
Okay, so we're gonna go over your homework from last night if you want to get out your sheets. A couple questions I noticed we did pretty poorly on.
So she knows which question she wants to go over.
One question we're gonna look at is this one here. 3 to the negative second times 3 to the negative 8. Common wrong answer was 1 over 9 to the 10. What's wrong with 1 over 9 to the 10?
Pause 1 second. 26 seconds into class, the teacher is actually talking about actually the most difficult question, okay, which was the one that says 27% here. And my animations didn't actually show circling that. But actually, teachers talking about common wrong answers that 56% of our kids got wrong, to me, is something really real and that our teachers actually like. So anyways, does assessments work? We actually, let's be clear, most systems don't work. The U.S. Department of Education has funded actually hundreds of millions of dollars actually in things. And most studies actually have shown actually either null results, mostly null results. And so IES is that institute that I was mentioning. This is me hanging out with Jeremy Rochelle, the gentleman actually at SRI that did the independent evaluation of us here. We happen to be in the halls of Congress. Anyways, if you go, it's a good book, and actually most things we actually don't know if they really work or not. In America here, actually, well, before this pandemic, you couldn't sell a drug without actually proving that your stuff worked. But in America, you could sell any piece of educational stuff, actually, as long as you can get people to buy it. There is actually something called the Warwick Clearinghouse. I'll mention it in a second. But I just want to point out that actually the best meta-analysis by Sternberger, Hu, and Cooper in 2013 analyzed these intelligent tutoring systems actually, and basically had this to say, which is the effect of these intelligent tutoring systems tends to be small and modest, and might actually also be contributing to the achievement gap. So that is actually, what we don't want is like stuff like this. So at West Point, actually, they actually did a nice study on actually the role of the flipped classroom. The flipped classroom idea was really popular a few years ago, and everyone was told, this is what you should go do. And a well-done randomized control trial at West Point actually showed that the flipped classroom on average was useful, meaning in the flipped classroom idea, and I don't really care to get into it so much here, but actually the big idea was teacher records lesson, kids actually watch lesson, then come to class and actually do stuff. Turns out, on average, that was effective, but it actually worsened achievement gaps. Okay, we don't want interventions that actually make the kids that are struggling the most actually like do worse from that. It would be like actually releasing a drug in America and giving it to everyone, but all the African American people actually get screwed by that. Right? And that works on average, but that's not good enough. We need to be able to take our educational technologies and test them with different populations and see, do they at least not make achievement gaps worse, if not actually at least improve them. Sadly, actually in the United States, you can get in the Warwick Clearinghouse without actually having demonstrated that actually you don't have disproportionate effects by different populations. Anyway, I'll just throw up another paper that actually is on the positive side, which is, hey, an active learning randomized control trial actually helps narrow achievement gaps. Like these are the types of interventions we actually want. I mentioned the Warwick Clearinghouse already a few times actually in preparation, but if you don't know, actually most in mathematics, there's very small number of interventions that have been reliably shown to actually be effective. I think there's 6 at the time I made this slide, I'm about to tell you about a study where we're one of them. This is a screenshot of actually these laptops. I think they're Macintosh laptops, whatever they're called, ProBooks or whatever they are. The governor of Maine, his name was Angus King. He bought laptops for every 7th and 8th grader in his state. You know when he did that? Almost 20 years ago. Okay, in 2002, Angus King bought laptops, Mac laptops for every 7th and 8th grader. In 2008, I realized this is a killer opportunity to run a randomized control trial because all the kids actually had the technology. All the teachers had the technology. They even actually gave out free internet, actually dial-up actually at the time. I actually built my system to make it really easy to go offline. Anyways, it's a great place to do a randomized control trial. I recruited 44 schools, handed them over to actually SRI. SRI put them into pairs based upon their demographics and randomized them into pairs. Half the teachers actually had to use their existing methods for 2 years, and then they could get trained on assessments, and the other half got going right away. And what were kids doing? Kids, they were doing 2 things. They were doing their textbook work, and I didn't want to get sued by our textbook publishers, so we didn't put the questions in, but we actually see this little slide in the bottom left-hand corner? Kid would open up their thing and it would say, open up your book to page 48 and go solve problem number 20. The kid does their work, does it on paper, types in the answer and gets feedback. I'll also note, see this slot where actually it says show answer? For that textbook work, there were no fancy hint messages as I showed you. There was just correctness only feedback. Let's just be clear, correctness only feedback is super powerful. We have so many kids wasting so much time without getting feedback at all in America. And so I'm going to tell you about actually our attempts to try to get slightly more intelligent feedback. But let's be clear, the single most important thing we need to do for every kid in America is get them immediate feedback in any shape, way, or form. A Google Docs or Google form is better than nothing, actually, or waiting until tomorrow. We also actually, a bunch of the teachers, I think 60% of them also gave out skill builders. These are these things I mentioned that actually you have to keep getting stuff right until you get 3 right in a row. This is the traditional sort of like repetitive math crap that you expect math programs to do. One thing that I think is really important to us is actually teachers get these reports. They can see exceeded daily limits. See this little red thing? This is a kid. If they got to 10 problems, we cut them off and we say, go talk to your teacher, okay? We're not just gonna give you more hints because on the 11th problem, what are the odds that you're gonna succeed? No, most educational systems don't wanna talk about actually the kids they fail. They just wanna actually talk about the average effects, but actually we wrote a whole grant around actually the kids that actually wind up putting in lots of effort and still failing. Because my system, just like everybody else's system, will actually fail kids. Meaning like they won't succeed actually. And so sometimes they need to really get teacher intervention to actually move forward. It's really easy to build stuff and then actually blame kids when they fail. When actually we should actually as designers take responsibility for the platforms that we're building. Anyways, this is a picture of actually Jeremy Rochelle talking at the White House about actually this study that came out in 2016. And I encourage you to go read it. The three main findings were teachers reliably changed their practices. They went over homework differently. Secondly, actually, we almost doubled student learning on average. But the most important thing is we started closing achievement gaps. We didn't come nearly close to closing them, but we actually made it reliably better, meaning kids that were below the median on their 6th grade math test actually learned essentially 2 years worth of actually learning. And we didn't do that by slowing down the high knowledge kids. The kids that were above the median on the prior year test, they still actually went up. They went up by 40%. But actually, my wife and I built an intervention that actually helps these kids. So how's the systems different than others? Like compared to things like Carnegie Learning's Matthew or McGraw-Hill or Alex, like my advisors created actually Matthew. And the idea is that if a kid learns something, we should let them go on, right? Like we don't want to hold them back. No, we should. Okay, I'm here to tell you the counterintuitive sort of thing, which is no, you should have the gut instinct that no, we actually don't want actually kids moving on. We want some amount of adaptation. What we actually, because here's what happens with these when the computer is totally in charge. And I've gone into some of these classrooms where you go to the computer lab. Some kids are on chapter 2, some kids are on chapter 23, and the teacher just taught chapter 11. The computer has nothing to do with what is going on in class. That is really wrong. That's not how we design platforms to actually help teachers do their job. That is the computer taking over, and I don't think it's good. I think we need teacher pacing, not just self-pacing. We do want some adaptation. I mean, actually on tonight's homework, there should be a little bit of adaptivity. So some kids that need a little bit more help actually need to be able to do some more problems. But actually we gotta, and I also just want to say sometimes randomizing problems isn't good. I'm going to show you an example here. This is Miss Razak. She's here in Worcester, Massachusetts. She's also getting a PhD with me. And this is just a random shot from her class. You'll see that actually she sees, and if you look very closely on this image, you'll see 80% of her kids said 1 to this problem. Let me help you do the math. And you can see actually on that little image, she just saw 80% of her kids said 1. And by the way, if you do the math out, they're doing order of operations wrong, right? They're adding the 4 and 3, and then doing the subtraction. That's the wrong order of operations. And so many computer-based systems will randomize all the problems. A teacher can never do this, right? Actually, if every kid is doing every problem, that's different. And so I think it's really important. So I'm now going to move into the crowd portion session of our talk. 4 years ago, during actually this big, huge study we had in Maine, I met this guy, Chris Lesige, and my chief future trainer introduced me and said, Neil, you got to meet this guy. Mr. Lesige is really actually amazing. He actually used my system to write feedback messages for every question in his book. But it was some random proprietary book sold by Pearson or McGraw-Hill or something. The few other teachers that were in the state of Maine that were using that same book, they couldn't actually take advantage of his hidden messages because I hadn't thought that anyone would ever do that. But he was just basically, he was mostly interested in just helping his own kids. So his kids got these extra hidden messages, but I hadn't done that. So I instead went and actually wrote a grant around that. And so, I'm going to talk about actually just-in-time student support, and particularly the hints and explanations is what I'm actually about to talk about. I'm about to talk about Mark Stanaporn, who's actually in this call right here, his work on that. I'm going to talk about a few other things, and I'm going to try to bring in my guest lecturer actually to talk about actually letting kids ask questions and to answer them. But let me actually talk a little bit about March's teacher assist work. So this is, I got actually funding from the U.S. the Office of Naval Research, believe it or not. We don't train sailors, but our Department of Defense actually has got a crazy way of thinking about actually how do they actually procure actually training materials. And some of the program officers actually have the sense that we should be crowdsourcing. Actually, we should be building platforms so that actually the master sergeants that know how to actually, you know, fix aircraft carrier lifts or whatnot can put their information into a platform that is then owned by the Defense Department, so they can stop paying outside providers to build actually stuff for them. So anyways, so March actually see this little blue link, I want to write a hint or explanation. Basically, all we did is we put that on the screen, and a teacher could actually click on that. They could actually then write a hint or an explanation. An explanation to us is actually where you just spew an explanation at them that will end with the answer, and hints are step-by-step little things. I wrote a hint of count on your fingers a few seconds ago, and that would be like a first level hint. We didn't tell them the answer in that. Anyways, we're exploring both of these. There's a cool blog that was done by the guy that actually was the teacher trainer. His name was Andrew Burnett. And here actually he's using the open educational resource known as Open Up. He wrote this blog about actually how he's back in the classroom now and uses assessments. And I just wanted to share with you the type of thing he does. And
so this is exactly what it looks like for the student. So let's say the student looks at this problem and they're not really sure how to solve it. So they just enter an answer and they answered incorrectly. It tells them that they're wrong because they've tried once and they're gonna try again and they get it wrong, and then they try it a third time and they answered incorrectly. Take a look at what pops up. It's a video that I made using the whiteboard app, Explain Everything. And then they just click on the video and the video will run.
So we have quadrilateral A here, and I'm going to make a little.
And it will take them through the problem, and it will show them how to solve the problem. And when they get all the way to the end, it will actually tell them what the answer is.
12. So the perimeter of the quadrilateral B.
Okay, pause. I'll tell you that actually Andrew Burnett, he says, hints suck, Neil. I actually write explanations. When my kids get it wrong, I give them this explanation, and then I actually give them another problem to do. We have yet to actually run a good randomized control trial showing actually hints versus explanations and when is that good. But we're right now building out a product that actually feature inside of systems to actually allow teachers to automatically assess and assign actually another, what we call a similar but not the same problem. And so these hint messages sometimes, at least Andrew actually kind of felt like, anyways, well, I'm leaving it up to as an empirical question. But I really believe that crowdsourcing is the future. The future of adaptive learning is the crowd holds the key. So anyways, March actually, who's here, he built out this experimental design. We call it the Star Teacher Framework. Basically, my wife, the beautiful woman in the middle, actually picked 9 teachers that she liked, that actually she thought would not embarrass us. And we basically paid them to actually spend an hour a night writing feedback for their own kids. I know that if I make a teacher write stuff that their own kids will see, they really curate their stuff. When they mess up and make an error, they really care, right? These teachers are motivated to care about their kids, not about like all these other kids. I care about all these other kids because I really just want to extract their explanations and see if I can actually see if they'll work for others. The textbook publishers would like us to believe this is not a good way of doing things. They really believe in consistency. Oh, every problem we should use the same language. The explanation should always be, really important. You can't actually just have this motley crew of 9 random teachers using multiple different textbooks to actually making explanations willy-nilly. Like what? Like, is someone going to beat Encyclopedia Britannica actually with a crowdsourced actually motley crew of random actually people making encyclopedia entries? I thought yes. So anyways, the big answer is we ran a randomized control trial where we actually, for all the problems where there's only one teacher assist, a teacher assist to us is either a hint or an explanation. If there's only one teacher assist, there was March actually would randomize it. 90% of the time they would actually, because I kind of thought this thing was going to be effective, so I didn't even do a 50-50 split randomized control trial. I did a 10-90. So most of the time actually kids were randomized into getting a teacher assist if there was one, but 10% of the time they wouldn't. So largely just so we could hold that out and see, does it matter? We assess student learning on the next problems. Turns out the main finding, please go read the paper. In fact, it just won best paper actually last week. And there's that actually amazing woman of my wife of mine that actually I already mentioned. She stopped gardening. And Anyways, she helped March actually get these teachers and organize all this. For some crazy reason, her name's not on the paper, even though she actually did have to work probably. You know, the other thing we found, teachers wanted to do this. We found 146 teachers actually who started writing actually teacher assists for themselves. Now, by the way, from my perspective, that wasn't even part of the study. Right? Like we picked these 9 teachers and only these people we trusted. But we had 29 teachers write over 50 actually assists, and we had 2 teachers write over 1,000. On the right-hand side, actually, March actually wound up showing me, look, Neil, all these other random teachers started making stuff for their kids. And they didn't do it thinking actually we were going to take their stuff and give it to the world. We're now going, and we've actually, I had one of my subject matter experts go and figure out which of these teachers' stuff do we actually want to actually release to the world. And about 80% of the stuff we kind of think, that's good, we won't get embarrassed if actually those explanations are put into the mix. Because what we really want to do is we want to really learn what are the types of explanations that are really important. And so we're really inviting the research community to actually help us think about that. In fact, I'm writing an exploration grant to try to see what are the features of these explanations. Some of these explanations were text, some of them were videos, some were actually, you know, by the way, gobs of teachers think they can do a better job than Sal Khan in writing little video explanations, and I think they're probably right. Like there's probably more, there's 30,000 7th grade math teachers. Actually, there's one guy named Sal Khan making videos at Khan Academy. That can't be the right actually solution. What we really want is we want to actually move on and actually be able to say, hey, what type of explanation should we give to what type of kid? And when I say that, we want a result like this, Razak and Heffron in 2009, to tutor or not to tutor, that is the question, where we actually had 2 different ways of giving feedback. One is, here's the complete solution. That is, we will spew text at you and tell you actually something, and you read it and you click, I have read this. And the tutor problem solving was actually, we will break the problem down into 3 steps and we'll give you hints on each step. Turns out what we found is lower knowledge kids, the kids that did actually below the median on the pretest, they really benefited from this step-by-step feedback. They learned more. The higher knowledge kids, actually, they actually benefited actually more from the solutions. Just give me the damn solution and let me read it. This is what a personalization effect is, right? Actually, we in America want to be able to detect these where we can kind of realize, oh, for this group of kids, and particularly the lower performing actually students that need all this assistance and the types of schools that I used to teach in Baltimore, we need to design stuff that really works for them, and that's what we're after. And so, but let's be clear, most of the 24 randomized controlled trials I've run, I think I've actually gotten maybe 1, maybe 2 interesting personalization effects. So everyone thinks we can personalize really well, but actually the science really showing how to do that well, and how to do that is by far actually not really there. Anyways, we right now are actually also trying to crowdsource actually explanations, and I'm going to give a shout out to my friend Andrew Land here in a second, because I want to move on. But we are crowdsourcing the explanations that we actually give to actually kids. Remember that teacher that actually asked kids, hey, why did so many kids say 1 over 9 to the 10th? And some girl actually said, I know, because they actually failed to they multiplied instead of added the coefficients of the exponents, or whatever that question was. Or I walked around my class. If you're a 7th grade math teacher, you know kids always fail to multiply the coefficient of the second term every time they do the distribution rule. And I would just say, oh, you failed to multiply the coefficient in the second row. Oh, hey, no, actually, it looks like you failed to multiply the coefficient in the second. Like I knew this was going to happen, right? You can predict it. Anyways, we should figure out though, what's the right thing to say? Do you just tell them actually you failed to multiply the coefficient in the second rule, or what's the right thing to do? We actually want to crowdsource those little explanations that will help a child not just know they got it wrong and why, but actually like why. Maybe the right thing to do is to show them the area model. And I don't have an example of that, but the area model is like why the distribution rule works. I'm also actually running an experiment actually funded by NSF and Ethan Prior, my PhD student, who's the one that's going to release the COVID data set in a few weeks. And he thought he was going to be able to do it today at this talk. But he right now is running actually our study where we're trying to figure out which YouTube videos actually we should give out. And so hold me to it. Actually, in a year from now, we should be able to tell you. I will say that one of my PhD students, Corinne Ostro, actually, her first experiment she ran at Assessments actually was video versus text. She saw our hint messages for Pythagorean theorem, put herself on video, and then wanted to figure out, do kids learn more if the exact same content is in video versus text? The general answer was yes, it is. Actually, 7th graders learn more with video. That's not always going to be the case. I think many of us PhD students actually, or PhD people, probably like, we're good readers. We actually can probably read faster than actually we can listen. But obviously this is always going to work in kindergartners where they can't even read, right? Actually, so the question is not, does video work better than text? It's like, for what types of kids is that actually likely to be useful? So I want to pause here. I want to hand it over to Andrew. Andrew actually and I are super excited about the general notion of how do we actually help actually let kids ask questions and crowdsource that. And so Andrew's student just gave a killer talk at the Educational Data Mining Society on his work. So Andrew, why don't you share your screen, and he's a young